So on your guided notes, you're expected to do a unit circle. So let me pull up the unit circle here, and I'm going to walk you through a little bit of it. You can look online to find a lot of this, but this is pi over 6 here, right? And you have pi over 3 here, pi over 4 here. This is pi over 2. Remember, we're not going to do degrees. These are all radians. 0 is right here. 0, if we did a whole circle, that would be 2 pi here. This over here is 2 pi over 3. Then we have 3 pi over 4, 5 pi over 6, and 7 pi over 6 here. This is 5 pi over 4. This is 4 pi over 3, 3 pi over 2. This is 5 pi over, this is 7 pi over 4. This is 11 pi over 6. So this is 5 pi over 3. Okay? So once you get all of that in, then you fill in the coordinates here. So this is going to be 1, 0. We said this was square root of 3 over 2, 1/2. This is square root of 2 over 2, square root of 2 over 2. This, remember, this is plus, plus, minus, plus, minus, minus, plus, minus. This right here is going to be 1/2 square root of 3 over 2. This here is going to be over 0 up 1. This one's going to be negative 1/2. So if you think about this triangle right here, right? This distance here will be negative 1/2 square root of 3 over 2. Negative square root of 2 over 2, square root of 2 over 2, and so on. And I'll let you finish that. So if you look at our notes, okay, our first question is, what is the, I believe it's the tangent value of 5 pi over 6. Okay, so let's go find 5 pi over 6. 5 pi over 6 is right here. Okay, so the question is, what's the tangent value? So I want to put the tangent value into these diamonds. All right, and that's something you're probably not used to. But remember, tangent is actually equal to sine theta over cosine theta. Okay, so let's just put this in. This one's negative square root of 3 over 2, positive 1/2. And this one's negative 1, 0. So what we want to do is take the sine value. Well, the sine value is this right value. So that's the sine of 5 pi over 6 here. And this value here is the cosine of pi over 6. So this is going to be 1/2 divided by negative square root of 3 over 2. And that's going to be 1/2 divided by negative square root of 3 over 2, which is equal to dividing fractions easy as pi, flip the second and multiply, and that gives me negative 1 over square root of 3, which if I rationalize it, which you don't have to, but if you do, it's negative square root of 3 over 3. How did I do that? I just multiplied by square root of 3 over 3 on the top and the bottom. Okay, so in the diamonds, I want you to put the tangent values. This is on your notes. It is also in your homework for tonight, which is the MML that you have to go sign up for. It's our textbook online. So this number right here is going to be negative square root of 3 over 3. You can also put negative 1 over square root of 3. That's the exact same thing. Okay, and what you'll see is there's kind of a pattern for the tangent values. If you're anywhere in this box right here, okay, all of these tangent values are going to be negative 1 over square root of 3, or negative, I'm sorry, not necessarily negative, but 1 over square root of 3. And this one's going to be 1 over square root of 3, and this one's going to be 1 over square root of 3. Now you just have to figure out if they're positive or negative. Well, in this quadrant, the sine value is positive and the cosine value is negative, so this must be a negative. In this third quadrant, this sine and cosine values are negative, so therefore this is a positive tangent, because negative divided by negative is positive. In the fourth quadrant, you have different signs for cosine and sine, so there's a negative here. And in the first quadrant, you have the same signs for cosine and sine, so you're going to have a positive tangent value. When you make a different triangle, if you make a triangle that's long and skinny, let's do a different color, like this triangle right here. Okay, it turns out that what you're going to do is you're going to divide the sine value divided by the cosine value. Okay, so this will be square root of 3 over 2 divided by 1/2. Okay, so that's going to be equal to, I'm calculating this tangent value right here, for pi over 3. So this is the tangent of pi over 3. Alright, it's the sine value divided by the cosine value, so that gives me dividing fractions easy as pi, flip the second and multiply. So what I get is square root of 3. And so it turns out the tangent value for all of the corners of this red rectangle, they're all going to be square root of 3, except for with different signs. So I need to figure out the signs, and again, I can just tell the signs by the quadrant. This quadrant has different signs for sine and cosine, so this is a negative tangent value. This is negative divided by negative, so that's a positive tangent value. And this is going to be a positive tangent value up here. And you actually don't have to write positive, but you do have to write negative, okay? And so what I do is I really just memorize all of these tangent values, okay? It looks like a big mess, maybe, but I just memorize it because it's easier to memorize it right than do the division right every time. And you might be a person who can do the division right every time. So more power to you if you're able to do that. Okay? So you're going to fill in all the tangent values in these diamonds. You're going to fill out, these are really easy, right? All these are ones somehow, 1 or negative 1. Up here, this is 1 divided by 0, right, which is undefined. So I'm going to call that undefined. Down here, this is 0 and this is negative 1. So this down here, the tangent value is negative 1 divided by 0, which is also undefined. The tangent value here is 0, 0 over 1, right, which is really 0. And the tangent value over here is 0 over negative 1, which is really 0. Okay, and you can figure out the rest of that. Now, what gets a little bit more difficult is when you have to find the inverse tangent. Okay, so before what we found was the tangent value. So we said the tangent of pi over 6 equals what? Okay, and I think we said that that was square root of 3 over 3. Okay, but now what if I said this value here is negative square root of 3 over 3? What is the angle? So let me rewrite this. This is saying if I had this problem, the tangent of what angle here will give me negative square root of 3 over 3. So if I go to my unit circle and I look where I have negative square root of 3 over 3 for my tangent value, that's here at 5 pi over 6, and where else is it? It's also here at 11 pi over 6. And the question is, which one is the answer? Okay, because what I do know is that the tangent of 5 pi over 6 is negative square root of 3 over 3, but I also know that the tangent of 11 pi over 6 is negative square root of 3 over 3. Okay, but there's actually only one answer, and the reason is because inverse trig graphs, if you were just finding this answer, okay, then you'd have actually an infinite amount of answers. But if you're trying to find this answer where you have, you're saying that the inverse tangent is a function, okay, then it doesn't repeat, which means it's bounded, okay? It's bounded between negative pi over 2 and pi over 2. So the inverse tangent value is bounded there. So where would I see that? Yeah, right here, negative pi over 2 and pi over 2, okay? Let's see right here, okay? So that means I have to choose the answer that's between negative pi over 2 and pi over 2. So let me go back and look at my circle. Here is negative pi over 2, right? It's down here. And pi over 2 is up here. Okay, so between negative pi over 2 and pi over 2 is kind of this semicircle over here, okay? And so it turns out that the answer is definitely not 5 pi over 6, okay? And it's actually not 11 pi over 6 either, because 11 pi over 6, I mean, you can put it in the calculator, is actually greater than pi over 2, okay? And we need a number that's less than pi over 2, but greater than negative pi over 2. So what is another way to say this angle here, this spot on the unit circle, that is actually, less than 0? So this is actually negative pi over 6. All right, so the answer to this problem here is negative pi over 6. Okay, and that's because this inverse tangent question is being asked as a function. And if this inverse tangent is a function, then it can't keep repeating. So it must be bounded by this range. And so we end up just memorizing this. If you're ever asked for the inverse sine, inverse tangent, or inverse cosecant, they all vary between negative pi over 2 and pi over 2. And if you're ever asked for the inverse cosine, inverse cotangent, inverse secant, then you have to give an answer between 0 and pi. Okay, if you go to my math lab for school, you can see where some of your homework will be, and also some of your, I think all of your tests this year. You're going to want to sign in after you register, and when I sign in, I'm not really sure if you guys see the same thing I see, but you're going to hit homework, and under homework you should see, there's a lot of homework here for you, but you should see this one homework called 1.1-1 Unit Circle Review with Orientation. Okay, so I think, I'm not really sure what you guys would hit. I think you just hit that homework, but for me, I'm going to look at student view, and you're going to go through an orientation first. It's not too terrible. It's going to help you practice using my math lab by entering the answer in and then hit check answer and such. And it shows you that there's different like blue things here where you enter numbers. Let's see, like if I wanted to enter something in here, if I want to enter x squared over 3, I would choose this fraction thing right here, then type x, and I can do a shift 6 to do a superscript squared over 3. Oops. Hitting my down arrow. That's 3. Check my answer, make sure that's correct. And you can go through this homework. I wanted to show you, I think it's problem 3. You'll have a unit circle. You need to fill in these parts, and if you've already gotten the unit circle done in your guided notes, then it's really just a matter of typing that in. So A here is the angle right here, and this is a 30 degree angle, so you're going to type pi over 6 here. And I just want to show you, this is kind of cool in Math Lab. You can just type pi and it turns to a pi. And if you want to do a fraction, you can just hit the slash bar. I'm just hitting the slash bar that's next to the question mark, underneath the question mark, and it does it divided by 2. Okay, and so you can, oops, I wanted a 6 there. So you can do that, okay, in order to enter all of these numbers in. So for letter B, this right here is pi over 3. So I would say pi/3. Okay, and that's a fast way to do it. So that's in here. You could also use this fraction bar here if you want to do that. So in here, I could actually hit this fraction bar to make a fraction and hit pi over whatever this one is. Okay? So you want to fill all of those out, and eventually you'll get some questions where you just have to answer the questions. Let me make sure. Let's see, you have to do these things here too, the coordinates, and you would just type the x comma y. So like at L, this is square root of 3 over 2, so I would put in here square root of 3, so here's the square root 3, and then I need to move, I'm going to hit my right arrow to move out of the square root, and then hit divided by 2. Then I need to move out of the 2, so I'm going to hit my right arrow, and I'll hit comma, and then this needs to be 1/2, so I can go down here if I want to hit the fraction and hit 1/2. Okay, and you would do that for all of these problems here. All right, and then later on in the next question, I think I asked you for the tangent values, and if you've done your unit circle, you'll just put the tangent values correctly in these places. All right, and then there's some questions to answer. I think the hardest questions might be at the end here. If you had a problem like cosecant -1, the inverse of cosecant negative square root of 2. Let me go ahead and copy this problem. You're supposed to use all this without a calculator, so if you're putting in fractions, it's not going to work. All right, so you need to do it. I'm sorry, if you're putting in decimals, it's not going to work. You'll have to put in fractions. You should be doing it without a calculator. So if I had a problem like this, how would I do it? Well, what is this really saying? This is really saying the cosecant of what angle is equal to negative square root of 2, right? Cosecant of what angle? So I have to figure out what this angle is, and this angle is going to be bounded right here between negative pi over 2 and pi over 2. So let me just figure out the angle first, the place where it goes on the unit circle. So this is pretty confusing. I don't know what cosecant is on the unit circle, but remember, I do know that cosecant theta is equal to 1 over sine theta, okay? And that's something you need to memorize. So if you go look at your guided notes, in your guided notes, you should have a bunch of things, a bunch of formulas that you have to have memorized. You should have memorized them in pre-calc, but it's not too late to memorize now. There's secant and there's cosecant, okay? So having memorized this, okay, this is going to help me to figure out what angle with the cosecant, what angle be negative square root of 2. So this means that if this is theta, this means that 1 over sine theta, okay, is equal to negative square root of 2, right? Because that is 1 over sine theta. Well, not really comfortable with 1 over sine theta, okay? But what I know is if I cross multiply, remember if you cross multiply, you have to have one fraction on the left, one fraction on the right, and equal sign in the middle. If I cross multiply, what I'll have is sine theta is equal to negative 1 over square root of 2. Okay? And how did I do this? I mean, just cross multiply that way. That would be negative square root of 2 times sine theta equals 1, and divide both sides by negative square root of 2. Okay? And this is equal to negative square root over 2 if I rationalize this. So now my problem's a little bit easier. My problem is at what theta is the sine value negative square root of 2 over 2. So if I go back to my unit circle, I know that the sine value is negative square root of 2 over 2 at two places. Let's see, at this right here, 7 pi over 4, and also right here at 5 pi over 4. Okay, now let me look at my boundaries for inverse cosecant function. That must be between negative pi over 2 and pi over 2. So again, I'm looking at this circle right, the semicircle right here, from negative pi over 2 to pi over 2, and so this 5 pi over 4 is not something I'm going to consider. Alright, so I'm trying to get my pen back. Alright, I'm going to consider the 7 pi over 4, but 7 pi over 4 is greater than pi over 2. Okay, 7 pi over 4, get my pen back, is actually greater than pi over 2, and I want something less than pi over 2. So this angle here, okay, is going to be negative pi over 3. Okay, because that negative pi over 3 is between negative pi over 2 and pi over 2, and that's where I need it to be. Alright, so the answer is negative pi over 3, and I don't know if you'll get the same question as that, but this right here is negative pi over 3. Okay, be careful. I think this step right here is where students mess up the biggest. Okay, a lot of times they flip things a little bit too quickly. What do I mean by that? Cosecant theta actually is equal to 1 over sine theta, but instead what students will say is that cosecant theta is equal to sine theta. Okay, and that's not true. They'll change this to sine theta, and they'll say that's equal to negative square root of 2, and then you'll get stuck because on the unit circle you can't find where sine theta is equal to negative square root of 2. Okay, so be careful with that. Alright, hope that helps.